Good morning, dear students. My name is Ferhan Mazher, and today we are studying the DMath 4024. This is Cambridge O levels mathematics. And today we are working on the concept of the angle properties of the circles. And today we have selected exercise 13C from the book D3. The name of the book is New Syllabus Mathematics 7th edition, book 3. This is the last chapter of that book, and this is the third exercise, exercise 13C, and this is my first video on this exercise. This exercise is related with the angles in the same segment are equal, angles in the opposite segment are supplementary. We also call this property the cyclic or the cyclic quadrilateral. Angles in the alternate segments are equal, angles in the semicircle is right angle. The angle at the center is 2 times angle at the circumference. So these are the properties on which this exercise is based, and this also involves the angle properties which you have studied in the exercise 13A and 13B. So if you want to see a complete lecture on all the circle properties which are used in this chapter, in the start of this chapter in the playlist of D3, in my YouTube channel, you can find that video where I have done a lecture on all the circle properties. So, and that will be very helpful to you. In this video, I'm not going to explain the properties, but we are going to solve the questions. A little bit I will explain, but the real lecture on the circle properties is a separate video. You can find that in the start of this chapter, where you find these videos in the start of that playlist. Before this chapter, you will find that video. Okay, so let's start this video, and we are starting from the question number 1, and we will try to solve maximum questions possible in this video, and then we will see that how many more videos we need to make. So let's start this video, and here we go. So this is exercise 13 and C. And we are going to solve its question number 1. So the question number 1 is showing up on your screen. Given that O is the center of each of the following circles, find the value of the unknowns. Okay, so here you have a circle. Here is the center. Here are 2 points on the circumference. You you join these points with the center. You also join these 2 points on the circumference with the circumference. And at the circumference, they subtend an angle of 40. So their question is, what is the angle subtended at the center? Remember, this is a very famous property. Angle at the center is 2 times angle at the circumference. So here you can see I have solved it, and A will be equals to 2 times the angle 40, and that A will be 80. So the reason is angle at the center is equals to 2 times angle at the circumference. This is the symbol we used for the circle. We make a circle, put a dot, and in the exponent we write CC. That means circumference. Okay. So you have to write the reason also that why the A is equal to 2 times 80. This is the angle at the center is 2 times angle at the circumference. Okay. Again, we have the question number 1 is B part. Here you can see we have a circle. This is the center. These are the 2 points on the circumference. You join these 2 points on the circumference with the center. You also join these 2 points on the circumference with another point on the circumference. So this is the angle. 60 angle is the angle subtended by that chord. Actually, this is a chord. Actually, this is a chord. Angle subtended by the chord at the center, and this is the angle. B angle is the angle subtended by the chord at the circumference. The angle subtended by the chord at the center is 2 times the angle at the circumference. So 2 multiplied B will be equals to 60. Let me show you. So here you can see the question is showing up. 2 times B will be equals to 60. The reason is angle at the center is 2 times angle at the circumference. So B will be equals to 60 divided by 2, and the B will be 30. So this is how you will solve this question, and let's go to the next question. So here we have 2 points. You join them on the circumference, so they will be making a chord, which is not shown here, but here it is a chord. You join the ends of the chord with the center. You join the ends of the chord with the circumference. You also join the ends of the chord in another with another point on the circumference. If you join this is the segment, the big segment, this is the small segment. Both these angles are at the circumference subtended by the chord, they are in the same segment, so their value will be same. So the 40 and the C, they will be equals to each other because they both are coming from the same segment and they are same chord and they are coming into the same segment. They are in the major segment. So these two angles at the circumference, they are in the same segment, so they will be equal. So the C will be equals to, here you see, these are the ends of the chord. You bring them on the circumference. You bring them here on another point on the circumference. So because both these points are in the same segment, so their values at the circle will be same. So C will be equals to 40, and the reason is the angles in the same segment. Angles in the same segment. Okay. So let's go to the D part. Here we have a circle, we have a center. This angle on this side is 230. This is the chord. Okay. You see, this is the chord and this is the major segment. This is the minor segment. You joined the ends of the chords with the circumference here, and this angle is D. And you know, this D angle will be half of this, or you can say 2 times D will be equals to 230. Angle at the center is 2 times angle at the circumference. So these ends of the chords have been joined with the center, and these ends of the chords have been joined with each other on the circumference. So the angle subtended at the center is 2 times angle at the circumference. So the next question is this, showing up on your screen. So 2D, 2 times angle at the circumference is equals to the angle at the center. So 2D equals to 230. So D will be equals to 230 divided by 2. And the angle D will be equals to 115 degrees. The reason is angle at the center is equals to 2 times angle at the circumference. Okay. So now we are going to the next question. Question number 1, it's E part. He says, here we have a circle, and this is the center. These are the ends of a chord. Here is a chord actually. Okay. So you join the ends of the chord with the center. You join the ends of the chord with the point on the circumference. You see, this is the angle subtended by the chord at the circumference, and this 110 angle is the angle subtended by the chord at the center. But there is a problem. This angle at the circumference does not have a relationship with this angle at the center. First of all, I have to find this angle. This is also the angle subtended by the chord at the circumference. So first of all, I have to find this angle. I will name it something and I will find out the total angle here will be 360. So from 360, I will subtract 110. So here we go. So let me call this angle alpha. So first of all, I will find this angle alpha. So angle alpha plus 110, angle alpha plus 110 will be equals to 360. So alpha will be 360 minus 110, alpha will be equals to 250. So if you want to find out the E is the angle subtended by the chord at the circumference, and alpha is the angle subtended by the chord at the center. And the angle at the center is 2 times angle at the circumference. So 2 times E will be equals to 250. So E will be equals to 250 divided by 2, and E will be 125. E will be 125. I have already checked the answers with the book, so they are good. If I put a tick there, they are good. Okay, so now we are going to the next question. The next question is question number F. Question number 1, it's F part. So here you have a circle, and in this circle, this is the center, this is a chord. You join the chord, the points of the chord with the center, and this is the angle at the center by the chord, and this is the angle subtended by the chord at the circumference. It's 40. So they want us to find out this angle, okay? So remember one thing, it's a very important fact. You should be able to recognize it. This is radius, you know, this is radius. And this one is also radius. So both these sides are equal. So this triangle here, because two of its sides are equal to the radius, so it's an isotriangle, isosceles triangle. And you know, in isosceles triangle, the angles opposite to equal sides, they are also equal to each other. We call them base angles. So if this is angle F, so this angle will be also F, okay? Because this is an isotriangle. This angle is 40, so the angle at the center here will be 2 times the 40, and then you will be able to find the F value. So let me show you. Okay. So this is radius, so they are equal. So this triangle is isotriangle. If this angle is F, this angle will be also F. Let me say this is angle alpha. So this angle alpha will be 2 times the 40 because angle at the center is 2 times angle at the circumference. So the angle alpha will be equals to 2 multiply 40, and that angle alpha will be equals to 80. So F plus alpha will be equals to 180 because this is an isotriangle. So F plus 80 equals to 180. 2F is equals to 180 minus 80. So 2F will be equals to 100. So F will be equals to 100 divided by 2. So F will be equals to 50. So this is how you will find this angle, and I hope you understand how this question is done. Okay, so we are going to the next question. The next question coming up on your screen is question number 1, and it's G part. Here we have a circle, and here you have a chord. You join the chord with the center. This angle here is 70. This line and this line is parallel. So it's a very important understanding that this is parallel, this is parallel. He gave in the question, he put these arrows. These arrows means that these lines are parallel. And if these lines are parallel, then this line here is a transverse line. So this angle is G, then this angle will also be G. This is radius, so it's an isotriangle. If this is G, this angle here will also be G because they will be the base angles of the isotriangle. Now, if this angle is 70, because this is a straight line, so the sum of this angle and this angle will be 180. So from 180, if you subtract 70, you will get 110 here. So 110 plus G equals to 180. Sum of the internal angles of a triangle is 180. So this is how you can solve this circle. You can find the unknown angles. So that's the strategy. So here we go. Okay, so question number 1 is G part coming up on your screen. So we know that, let me say, this is radius, this is radius. So these two angles, they will be equal to each other because this is an isotriangle. And in the isotriangles, the base angles, the angles which are opposite to the equal sides are also equal to each other. So these are the base angles. So the alpha, I named it as alpha, I just named it alpha, and this will be also alpha. Let me call this beta. Now, the first thing is that the alpha will be equals to G because they are alternate to each other. So beta plus 70 will be equals to 180. So the beta will be 180 minus 70. So beta will be 110. So in this triangle, alpha plus beta is equals to 180. The sum of internal angles of a triangle is equals to 180. Alpha is equals to G. So G plus 110 is equals to 180. So 2G is equals to 180 minus 110. 2G is equals to 70. G is equals to 70 by 2. So G will be equals to 35. So my dear students, this is how you will solve this question. I have reduced the size of this question so you can see the whole question together. So in front of you, you can see this whole question is showing up. I hope you understand this question. Okay. So the next question is question number 1, and it's H part. Here we have, this is a chord. Remember, this is a chord. And when you join the ends of the chords with the center, the angle is 98. You join the ends of the chords with the circumference. The angle here will be half of the 98. The angle subtended at the center is 2 times the angle at the circumference. So the angle at the circumference will be half the angle at the center. So this is a radius. This is also a radius. The angle here is h. The angle here is 21. So our strategy is very simple. I join this point center with this point of the circumference. So this will be also a radius. This will be an isotriangle. On this side, it will be also another isotriangle. So if this angle will be h, this angle will be also h, this angle will be 21, this angle here will be 21. So 21 plus h will be equals to half of the 98. So let me show you my working. Okay. So here you can see this is radius, this is radius. I myself joined the O with this circumference, the point on the circumference here. So this is also radius. So this angle h and this angle will be same. And this angle and 21 will be same. Okay. So let me say this whole angle is gamma. This whole angle is gamma. So 2 gamma is equals to 98. Angle subtended at the center is 2 times angle at the circumference. So gamma will be equals to 98 divided by 2. So the gamma will be 49. So this whole angle at the circumference, that's 49, half of the 98. So then this alpha and h, they are equal because this is an isotriangle. These two sides are equal. This beta and 21, they are equal because it's an isotriangle. This is radius. This is also radius. So it means that alpha plus beta here is equals to gamma. Alpha is h and beta is 21. Gamma is 49. So h will be equals to 49 minus 21 and h will be equals to 28. So this is how you will do this question. I hope you understand this question. The whole of the question is showing up on your screen. You can pause the video and you can take your time and you can, I hope you can do this question. Remember one thing, whenever we teach face-to-face, my students, whenever I teach them, they do these questions themselves, okay? So these videos actually means that if you are somewhere where you don't have an expert teacher on this topic, so by watching this video, you can do it on your own, okay? So, but actually you will learn from here, then do this question on your own independently. Then you will actually learn, okay? So this was the question number 1, and let me show you. This was the question number 1. We have done A, B, C, D, E, F, G, H part. Okay, so we are going to the next question. The next question coming up on your screen is question number 2. It says, given that O is the center of each of the following circles, find the value of each of the following unknowns. Okay. So the first question, A part, here we have a diameter. This is the diameter because passing from the center, joining the 2 points on the circumference. So this is the diameter. So when you join the ends of the diameter with the circumference, remember the angle at the circumference by the semicircle is 90 degrees. If you join the ends of the diameter with a point on the circumference, the angle will be 90. The angle subtended at the circumference by the diameter is 90. We call it right angle in the semicircle. Okay. So this angle here will be 90. This 90. This is 40. The A will be the question. This is a triangle. The sum of the internal angles of a triangle is 180. So very simple and straightforward question. Okay. So let me call this as angle alpha. So the angle alpha will be 90. The reason is right angle in the semicircle. Now I will add these 3 angles and their sum will be equal to 180 because the sum of the internal angles of a triangle is 180. So A plus 40 plus alpha will be equals to 180. So A plus 40 plus 90 equals to 180. So A plus 130 equals to 180 and A will be equals to 180 minus 130. So A will be equals to 50. So this is how you will do this question. Hopefully you understand. The question is showing up on your screen. You can pause the video and take your time. Okay, so we are going to the next question. The next question is question number 2, is B part. Here again, we have a diameter, and how do I know diameter is passing through the center, joining the 2 points of the circumference. So this is the diameter. So if you join the ends of the diameter with another point on the circumference, the angle formed here is 90. You see this side and this side is equal. This is given in the question. So this is an isotriangle. So the angles opposite to the equal sides are also equal to each other. So this angle is B. So the angle here will be also B because it's an isotriangle. So then I can very easily find the B value. B plus this angle will be 90 equals to 180. B plus 90 equals to 180. So here we go. B plus, let me call this angle beta, and this angle alpha. The angle alpha will be 90. The reason is the right angle in the semicircle. The angle B will be equals to the angle beta will be equals to the angle B because it's an isotriangle. They have told us by showing these points, these marks here. So if I add the three angles of this triangle, their sum will be equals to 180. So alpha plus beta plus angle B equals to 180. So 90 plus B, and the beta is also B, plus equals to 180. So 2B is equals to 180 minus 90. 2B is equals to 90. B is equals to 90 by 2. So B will be equals to 45. So this is how you will do this question. And let me reduce the size so the whole question. Yeah, now the whole question is showing up on your screen. So my dear students, you can pause the video and you can take your time. And I hope you understand this question. So that was the question number 2 from the exercise 13C D3. Okay, so we are on the question number 2. It's C part here again. This is the diameter. Remember, this is the diameter. And the angle, this full angle will be 90. Okay, so do you understand this? This is radius, this is radius, this side is a chord. And they have put these marks. These marks mean that these three sides are equal. So if these three sides are equal, this is an equilateral triangle. Remember, equilateral triangle, the three sides are equal. And if the three sides are equal, its internal angles are also equal to each other. In the equilateral triangle, each internal angle of the triangle is of 60. So this angle is 60, this angle is 60, this angle is 60. So this is the chord. You joined it with the center. This angle will be 60, and you join the chord with the point on the circumference. That angle is C. So the C will be half of the 60. I hope you understand. Let me show you how this is done. Okay, C part. So because this triangle is equilateral triangle, so all the three angles will be equal, alpha, alpha, alpha. So 3 alpha equals to 180, alpha equals to 180 divided by 3. So alpha will be 60 because this is equilateral triangle. This is the chord. You join, and alpha is the angle subtended by the chord at the circumference, and the C is the angle subtended by that chord at the circumference. Alpha is the angle subtended by the chord at the center. I said circumference, sorry, at the center. So you know the angle subtended at the center is 2 times angle subtended at the circumference. So 2C is equals to alpha. So C will be equals to alpha by 2. Alpha value is 60. So C is 60 divided by 2. So the C is 30. So this is how you will do this question, and hopefully you understand this question. So this is a question showing up on your screen. You can pause the video and take your time, but I'm going to the next question. So here we go, another question. So here, this is a diameter. This is also a diameter. This angle is 30. This angle is D. So, you know, this angle will be 90. This also will be 90. And this angle will be 90 because the angles in the semicircle. Very easily, I can find this D value. Let me show you what I have done. So you can see, suppose this is the chord, and you join the chord with the circumference. Angle formed here is 30. You again join the same chord with the circumference on the same segment, in the same segment. So this angle is alpha. So this alpha and this 30 will be equal because of the angles in the same segment. And because this is the diameter, and you join the ends of the diameter with the circumference, so this whole angle is 90. This is called right angle in the semicircle. So alpha plus the angle D will be 90. So 30 plus D is equal to 90. So D will be equals to 90 minus 30. So the angle D will be equals to 60. This is called the right angle in the semicircle. So that is question number 2. It's D part. My dear students, you can pause the video and you can take your time with this question. So let me increase the size of this question so you can see the whole question. Okay, so this is how you will do question number 2. It's D part. So my dear students, now we are going to the question number 3 of the exercise 13C and D3. Find the value of each of the unknowns. Here we have, this is the center, this is the diameter, this is also the diameter. These are the parallel lines. So if these are the parallel lines, you know, because this is radius, this is also radius, this will be isotriangle. These two will be the base angles. So this x and the 50 will be the same. So x value will be 50. So very simple and straightforward question. Property of the parallel line, angle properties of the parallel lines has been used here. You see, this is parallel, this is parallel. So this is radius, this is radius. So it's an isotriangle. So this angle and this angle, they are the base angle of this isotriangle. So they will be equal to each other. So simply the x is equal to 50. The reason is they are the base angles of the isotriangle. Question number 3A part, very simple. Isotriangle, with that isotriangle we solved it. Okay, here we have question number 3, it's B part. So look at this question. And this, let me increase the size so you can see it more clearly. We are looking for the B part. Okay, so here is the B part. So this angle is 100, this is 68, this angle here is y. You see this angle, this is that chord. Remember, this is that chord. And you join the chords, the ends of the chord with the point on the circumference here. The angle formed is 68. You again join the same chord, its ends with the point on the circumference here. So this angle will be also 68. So 100 plus 68 plus y, that will be equal to 180. The internal angles of the triangle, their sum is 180. So this is how you will find the value of the y. So, okay. So here we go. So suppose suppose this is chord. So I'm coming with another strategy. So suppose this is the chord and you join the ends of the chords with the point on the circumference. So this angle is beta. So this angle is y. So this and this, they are in the same segment. So beta and the y, they are same. So beta and the y angles in the same segment. So beta is y. This angle is 100. This angle is alpha. They will be equal to each other, because they are vertically opposite angles. So this alpha will be also 100. So if I add these 3 angles, their sum will be equal to 180. So the beta plus alpha plus 68 is equal to 180. So y beta is equal to y plus 100 plus 68 equals to 180. So y is equals to 180 minus 168. And the y will be equals to 12 degrees. So this is how you will do the question number 3 and its B part. I hope you understand. So this is showing up on your screen. I told you another strategy. If this is 68, this angle is 68, y plus 68 plus 100 equals to 180. So by this methodology also you can find the angle of y. Angle y you can find by this strategy also. That is much easier. Okay, so that was the question number 3 and its B part. Okay, so my dear students, we are going to the next question. The next question coming up on your screen is this one. Okay, so there's a question number 4, and in the figure, the TPQ, this whole angle is 100. The PSQ, this small angle here is 20, and they want you to find out the PQT. They want you to find out PQT. PQT. The strategy is very simple. Look at this chord PQ. Look at the chord PQ. Let me increase. So I will show you the strategy. Very simple strategy. Look at this chord PQ. You join the chord PQ, it ends with the circumference at the point S. The angle formed here is 200. You join the ends of the chord PQ with another point on the circumference at the point T. So this angle here will be also, that's the angle in the same segment, it will be also 20. So 100 plus 20 and the PQT will be equals to 180 because this is a triangle. And you can find the angle PQT very easily. So this is coming up on your screen, the question number, this is question number 14. So it's showing up on your screen, the whole question. Okay, so this whole angle is 100, this angle is 20. Let me call this angle as alpha. The angle alpha is equal to the angle 20 because they are the angles in the same segment. So now PQT triangle, look at this triangle. The angle PQT plus the 100 plus the alpha will be equal to 180 because the sum of the internal angles of a triangle, the sum is equal to 180. Okay, now alpha is 20. This angle is, we have to find out this angle is 100. So here you can see that that calculation has been shown here. So 100 plus 20 plus PQT angle is equals to 180. So the PQT angle is equals to 180 minus 120, and that will be 60. So this is how you will do that question. So my dear students, the whole question, question number 4. You can pause the video and you can take your time to do this question. I hope you understand how this is done. That's how you do the question number 4. Okay, so we are going to the next question. The next question is question number 5. He says, in the figure A, B, C, and D. Sorry. In the figure A, B, C, and D are the points on the circle, such that AD produced meet the BC. AD produced meet the BC produced at the point X. So AD produced and the BC produced, they meet at each other at point X. Given that the angle CDX, the angle CDX, that's 65, find the angle ABC. They want you to find out this angle. So try to understand this strategy. You see ADX is a straight line. So this CDX angle is 65. So I can very easily find the ADC angle. Their sum will be equal to 180. They are the sum, they are the adjacent angles on a straight line. So their sum is equal to 180. So I can 180 minus 65, I can find this angle. Okay. Once I know this angle ADC, look at this ADCB, ADCB, ADCB. It's a cyclic quadrilateral. It's a quadrilateral whose the 4 vertices are on the circumference. So it's a cyclic quadrilateral. So the sum of the opposite angles in the cyclic quadrilateral is 180. So we call it the angles in the opposite segments are supplementary. So this angle ADC and the ABC, their sum will be equals to 180. Angles in the opposite segment are supplementary. So this is how you will find the angle ABC. Okay, so let me show you very easy and straightforward question. So the angle ABC is the question. Let me call it this angle X. X plus 65 is equals to 180. The reason is the sum of the adjacent angles on a straight line is equals to 180. So the X is equals to 180 minus 65. So X will be equals to 115. So I know that the ADC angle is 150. Now this is a cyclic quadrilateral ABCD. ABCD is a cyclic quadrilateral. Its 4 vertices are on the circumference. So this is a cyclic quadrilateral. So the sum of the opposite angles in the sum of the angles opposite angles in the cyclic quadrilateral on the vertices. Their sum will be equals to 180. We call it the angles in the opposite segments are supplementary. So the angle here ABC and the angle this, their sum will be equals to 180. The angles in the opposite segment are supplementary. So the ABC plus the 115 equals to 180. So the angle ABC will be equals to 180 minus 115, and the angle ABC will be equals to 65. So this is how you will do the question number 5. Let me reduce the size. Now, the whole question is showing up on your screen. You can pause the video and you can take your time with this question. Okay. So here we have the question number 6. In this is find the values of the unknown. So question number 6, its A part is coming up on your screen. This is the diagram. We have a circle here. This is a cyclic quadrilateral, you can see. This whole angle is 110, this angle is 70, this angle is X. So very easily I can find this whole angle here. It will be 180 minus 110 because its angles in the opposite segment are supplementary. So once I know this angle, I will add 70 this angle and I will find X equals to, and that will be equals to 180. The sum will be equals to 180. So you can find very easily the value of the X. Okay. So I might solve. Okay. So here I have done in a little different strategy. You can see this is the chord. There can be many strategies, remember. This is a chord and you take the ends of the chord to the circumference. This is the angle X. Same segment, same chord, you take them here. So let me call this angle as beta. So this beta will be equals to angle X. And you see this chord, you bring this chord on the circumference here, the angle is 70. The same chord, you take its ends to the circumference here. So this angle is, let me call it alpha. So this alpha will be equals to 70. So this is 70, this angle will be X, and this whole angle is 110. So 70 plus X will be equals to 110, and you can find the value of X. So alpha is equals to 70, angles in the same segment. Alpha plus beta is equals to 110. So alpha is 70, beta plus beta equals 110. So beta is equals to 110 minus 70. So the beta will be equals to 40 degree. So X will be equals to beta, this angle here, and this angle, they are angles in the same segment. So X will be equals to 40. So this is how you will do this question there. Remember to solve a question, there can be many strategies. This is one of them. When I explained you this question, I gave you another strategy. So there can be many strategies to do this question. This is one of them. So pause the video and take your time. Okay, so we are going to the next question. The next question is question number 6. On the B part, you can see a circle here. It's a cyclic quadrilateral. This triangle angle here is 54. This is an isotriangle. This triangle here is also, because of these symbols, this means this and this side is equal. This side and this side, they are equal to each other. So this is isotriangle. This one is also isotriangle. This is angle Y. This is angle Y. And this is 54. This angle will be also 54. You can find this angle. You can find this angle. This will be 180 minus 2y. This angle will be 180 minus 54 minus 54. And the sum of this angle and this angle, because angles in the opposite segment, the sum will be 180. So we can find the value of that. Okay, now let me suppose this is showing up on your screen. So this is isotriangle, this is 54. Let me say this is alpha, this is beta. So the alpha will be equals to 54 because these are the base angles of the isotriangle. So in this triangle, 54 plus beta will be equals to 180. So 108 plus beta is equals to 180. So beta will be equals to 180 minus 108. So beta will be 72. So this angle is 72. Now I can find this angle. Let me call this angle gamma. This is a cyclic quadrilateral. These are the angles in the opposite segment. Their sum will be equals to 180. So gamma plus the beta is equals to 180. So the angles in the opposite segment are supplementary. So gamma plus 72 equals to 180. So gamma will be equals to 180 minus 72. So the gamma will be 108. So the angle gamma will be 108. Now I want to find out the value of the x. This is iso. This is also isotriangle. So x and this y, they will be equal. So y plus gamma equals to 180. 2y equals plus 108. Gamma value is 108 equals to 180. So 2y is equals to 180 minus 108. So 2y is equals to 72. 2y is equals to 72. So y will be equals to 72 divided by 2. So y will be equals to 36. So this is how you will do this question. So let me reduce the size so you can see the whole question. So because this question was on the whole page. So so you can see this question, the question number 6 and its B part. The whole question is coming up on your screen. I hope you understand this question. So let's go to the next question. So the next question is question number 6 and its C part. So this is also iso triangle. This angle is 41. So this angle will be also 41. So 41 and this angle will be 27. So it will be 41 plus 65 plus 27 plus x will be equal to 180. This is a very simple strategy. This angle and this angles are angles in the same segment. This angle 27 and this angle, they are angles in the same segment. So then this will be a triangle. So very easily we can solve it. And let me show you question number 13, 6. C part coming up on your screen. Okay, let me call this angle beta. Let me call this angle alpha. And this angle alpha will be equals to the angle 27 because they are the angles in the same segment. You can see this is the chord. And when you bring the ends of the chord here, the angle is 27 at the circumference. So you bring the same chords ends on the circumference here. So this angle alpha will be also 27 angles in the same segment. In the same way, if you look at this chord, look at this chord, you bring the ends of this chord here at the circumference, the angle is 41. So when you bring the ends of this chord on the circumference here, the angle is beta. So beta and the 41, they will be equal to each other because they are the angles in the same segment. So the beta is 41, alpha is 27, angles in the same segment. So now if you look at this triangle, x and this whole angle and this angle, their sum will be equal to 180 because the sum of the internal angles of a triangle is 180. So beta plus 65 plus alpha plus x is equals to 180. Beta value is 41 plus 65, alpha value is 27 plus x is equals to 180. So 133, if you add these three, it's 133 plus x is equals to 180. So x will be equals to 180 minus 133. So x will be equals to 47. So this is how you will do the question numbers. The question number 6 and its C part is showing up on your screen, and you can pause the video and you can take your time with this question. So this is how you will do question number 6 and its C part. Okay, so now we are on the question number 6 and its D part, and you can see this is the D part coming up on your screen, and so you can see it very clearly. So this is the diameter of this circle, and this angle here is 40. This angle here will be how much? 90. So very easily I can find this angle 40 plus 90 plus this angle will be equals to 180. It's a triangle. Once you know this angle, you can see this is a cyclic quadrilateral. Okay, so y plus whatever will be this angle, their sum will be equals to 180 because angles in the opposite segment, they are supplementary. So that is the strategy which I am thinking right now. Let's see how I have done when I solved it actually. Okay, so I named it this angle x, this angle w. So x will be equal to the 90 because you bring the ends of the diameter to the circumference. So we call it the right angle in the semicircle. So the x will be equals to 90. Now I can find the w. W plus x plus 40 will be equals to 180. So w plus 90 plus 40 equals to 180. So w will be equals to 180 minus 130, and the w will be equals to 50. Now, once you know the value of the W, you can see this is a cyclic quadrilateral. So Y and the W, they are the angles in the opposite segment. Their sum will be equals to 180. So Y plus W will be equals to 180, and Y plus 50, W value is 50. So the Y plus 50 will be equals to 180. So Y will be equals to 180 minus 50. So Y will be 130. So my dear students, I hope you understand this technique, and this is the whole question. And the question number 6 is D part and is showing up on your screen. So this is how you will do this question. You can pause the video, take your time to absorb that question. Okay, so that was the question number 6. Okay, now we are on the next question. The next question is question number 7. In the figure, A, B, C, and D are the points on the circle such that the AD produced meets the BC produced at the X. Okay, so given that the ABC angle here is 80 degree and the AXB is 30, find the BAD. They are asking you to find this angle BAD, and then they want you to find out the XCD. Okay, very simple. Okay, so if you look at this big triangle ABX, look at the triangle ABX. This angle is 30, this angle is 80. So I can find this angle. That will be very simple, 180 minus 80 minus 30, and you will get the angle BAD. So once you know this angle, now look at this. This is a cyclic quadrilateral. This is a cyclic quadrilateral. So if this angle and this angle here, they will be the angles in the opposite segment. Once you know this angle, you can find this angle. Because their sum will be 180, so you can find this angle BCD. Once you know the BCD, then this is a straight line. So from 180, subtract this BCD angle, you will get the XCD angle. So that is the strategy of the question number 7. Okay, so let's do this. Question number 7, the strategy is very simple. And you see, this is question number 7. Yeah. So that this is the question BAD. They are asking you to find out. This is a big triangle BAX. Suppose this angle is 80, this angle is 30. So I want to find out this angle. So it will be 80 plus 30 plus BAD equals to 180. So the angle BAD will be equals to the 180 minus 110, and that will be 180 minus 110, and that will be BAD angle will be equals to 70. So this angle here, BAD angle is 70. Now the next question is, now you can see this angle and this angle, they will be angles in the opposite segment. Their sum will be 180, so I can find the BCD. So let me call it alpha. So alpha plus 70 equals to 180, angles in the opposite segment. So the angle alpha will be equals to 180 minus 70. So alpha will be equals to 110. So once I know this angle, because this is a straight line, so the sum of this angle and the XCD will be equals to 180. The sum of the adjacent angles on a straight line is equals to 180. So the XCD plus the alpha will be equals to 180. So XCD plus 110 is equals to 180. So XCD equals to 180 minus 110. So the XCD angle will be equals to 70. So this is how you will do this question. And let me say this is question number 7. And both of these parts, I will reduce the size of this slide so you can see but this size becomes very small. I hope you can see this whole question. You can pause the video, then you can zoom in. And the whole question is showing up on your screen, and I hope you can understand this question. So this was the question number 7 from the exercise 13C from the book D3. So So the next question coming up on your screen is the question number 8. He says in the figure, O is the center of the circle. So this is angle O, this is a circle, and this is the center O. And they want you to find the sum of the PQR. PQR, this angle will be 90. This is the right angle in the semicircle. So this angle will be 90. The PRS and the PTS. PRS and the PTS, they are talking about this angle and they are talking about this angle. This is a cyclic quadrilateral. These are the angles in the opposite segment. So their sum will be equals to 180. He wants you to find out the sum of these three angles. You don't need individual values. This is 90 and the sum of these two will be 180. So when you add these three, it will be 180 plus 90 and that will be 270. A very simple and a straightforward question. So let me show you that question. So here we have the question number 8. So we have here PQR plus the PRS plus the PTS. This is the question they ask you. They want you to find out the sum of these three. This angle will be 90 because this is right angle in the semicircle. The sum of these two angles, they are the opposite angles in the cyclic quadrilateral. Angles in the opposite segment, they are supplementary. So their sum will be 180. Sum of these two will be 180. This angle is 90. So 90 plus 180, that will be 270. So this is how you will do the question number 8. So we are going to the next question. The next question coming up on your screen is question number 9, and it's A part. So question number 9, it's A part here. And here we have a tangent, and this is a triangle. The triangle is such that if one point is on the point of the contact between the tangent and the circle, we call it the point of tangency. And the angle between the side of the triangle and the tangent is 40. This angle will be equal to this angle. The important thing about this triangle is all 3 points are on the circumference, and one of its vertices is on the point of the tangency. So the x is equals to the angle 40, the angle between the side and the tangent, and the angle opposite in the, that will be equals to so the angle x will be equals to the 40. The reason is angles in the alternate segment. I have shaded this so you can have a better understanding. So this is a tangent, this is a triangle. The triangle's 3 points are, the vertices are on the circumference. So the angle between the tangent and this side will be angle opposite in the triangle. So this is x is equals to 40. We call it angles in the alternate segment. Okay, again we have the question number 9, and it's B part. Let me increase the size so you can see the whole question. Neat and clean, nice and clear. Okay, so this is our triangle. This is the point of tangency. This is the tangent. The 3 vertices of the triangle are on the circumference. This angle is between the tangent and one of the sides of the triangle. So this angle 60 and this angle here will be also 60. We call it the angles in the alternate segment. They are equal. So once you know this angle 60, 60 plus 70 plus y will be equals to 180. So angle alpha will be equals to angle 60. This is called the angles in the alternate segment. This is the triangle. These 3 vertices are on the circumference. One vertex is on the point of tangency. So the angle between the tangent and one of its sides will be a angle opposite internal angle. So this angle alpha will be 60. We call it the angles in the alternate segment. So this angle, once you know this is 60, so y plus alpha plus 70 is equals to 180. So y will be equals to 60 plus 70 plus y will be equals to alpha plus 70 equals to 180. Y plus 60 plus 70 equals to 180. So y plus 130 is equals to 180. So y will be equals to 180 minus 130. So y will be equals to 50 degrees. So this is how you will do this question. This is question number 9, and it's B part, and the whole question is showing up on your screen. You can pause the video and you can take time and absorb this question. So now we are going to the next question. The next question is question number 9. It's C part. Here we have a triangle. Its 3 vertices are on the circumference. This vertex of the triangle is at the point of tangency. and the side of the triangle makes 44 angle with the tangent. So this angle and this angle here, they will be equal. We call it angles in the alternate segment. So once I know this angle, then 59 plus 44 plus x will be equals to 180. So very simple and straightforward strategy. So let me call this angle as alpha. This is 44. Let me call this angle as alpha. So alpha will be equals to 44. The reason is angles in this alternate segment. So once I know this is 44, 59 plus 44 plus x, and x is the question, basically x plus alpha plus 59 is equals to 180. So x plus 44 plus 59 is equals to 180. So x will be equals to 180 minus 103. So x will be equals to 77. So the value of the x is 77. So my dear students, this is how you will do the question number 9. It's C part. The whole question is showing up on your screen. You can pause the video and you can take your time and solve this question. Okay, so this is the last part of the question number 9. Question number 9D part from the exercise 13C from the book D3 New Syllabus Mathematics 7th edition. Okay, so here we have a tangent, here we have a triangle. The three vertices of the triangle on the circumference. One of the vertex is on the point of tangency. This is the angle y between the tangent and the and the side of that triangle. So this angle and this angle will be same. Okay, so 43 plus 81 plus y will be equals to 180. So very easily you can find the value of the y. Okay, so I have named this angle as angle alpha. So 81 plus 43 plus alpha will be equals to 180. So alpha plus 81 plus 43 equals to 180. So alpha will be equals to 180 minus 81 minus 43. So alpha will be equals to 180 minus 124, and alpha will be equals to 56. So once I know this alpha and the y, they will be same. They will be equal angles in the alternate segment. So the value of the y will be 56. So this is how you will do question number 9, and it's D part. So we are done with the question number 9. The next question is coming up is question number 10. So I think it's enough for this video. So my dear students, today we have done how many? We have done how many questions? We have done from the exercise 13C D3, and this is the first video on this exercise, and we have completed from question number 1 to question number 9. So I hope that this video will help you. It will make your life little easier, your parents' life little easier, and it will help the teachers also. And the rest of the questions of the exercise 13C, I will do in my next video. So if you find this video useful, interesting, and you think it can help you and your friends and your junior students, please share the link of this video with your class fellows, with your junior students, with your teachers, with your friends. Also like this video and also subscribe my channel, because this gives me appreciation. This is a big appreciation for me. So thank you very much, everyone. It's a great blessing for me to be able to teach you through this YouTube channel. It's a blessing for me. So thank you very much. Have a good day. God bless you all.